let's see a visualization of that, right? So this one, the visualization that we're going to see is nothing but just the same thing that we've done over here, right? So I'm going to use bar plot to actually do that. So I first set my figure size, and I'm going to use bar plot for that, which is I'm going to use C1, right? And we're interested in the airline and the price and also the total stop, right? The total stop. So that's what I'm actually going to do over here, right? So all these are just certain labels, the ticks, the rotations, and all these are just some hyperparameters you can tune by yourself. All right, so over here you can actually see that if you pick say indigo, right? So the colors, if you see the colors, green represent one stop, you see the blue for 2 stops, and then red for non-stop. We also have 3 stops and 4 stops in there, right? So if you pick indigo, green is for 1 stop, right? So you can see that the highest price over there is for the 2 stops, right, followed by the 1 stop, and then the non-stop is the least price over there, right? If you pick say Air India, you can actually see that 4 stop cost the highest, right, and then followed by 3 stops. So right, so the higher the stops, the higher the price that you're going to pay, right? If you pick say Jet Airways, right, business, you can see that for Jet Airways business, 1 stop cost higher, very high than say 2 stops, right? So that one is actually kind of different from the others, right? It's just kind of an aberration over here. You can see that that's for that one, the 1 stop cost higher than the 2 stops, right? That's for Jet Airways business class. All right, so this actually gives you an overview of your data set and how the number of stops are actually related to the various prices. So let's see the count of the sources. So we have these sources. We have Delhi, Kolkata, Bangalore, Mumbai, and Chennai in there, right? So we can see the source and then the price also, right? You can see the source and then the price, since we are interested in the source and then the price. So over here I pick the price and then the source over here. The data of course is coming from my DF data, and then I'm going to sort it with respect to the price in ascending order, right? So that's what I'm going to do over here, and I'm using bar plot to do that, right? I set my figure size over here too. Now if we do that, we can actually see the various. We can see that Delhi is the one with the highest price, right? Is the source with the highest price in here, right? Delhi is the source with the highest price, followed by Kolkata, right? So you can actually have, followed by Bangalore in here. So you can actually have an overview of these various sources and the prices. Okay, so let's do the same thing for destination and then the price too, right? So earlier on we did it for price and then the source. So we're going to do the same thing for destination and then the price. It's just the same code, but in this case, instead of source, we are just replacing the source with the destination, right? So it's just the same thing that like the one we did over here, right? So we're just replacing the source with destination. Now if you see that over here, right? So these are the various destinations that we have. We have New Delhi, we have Cochin, we have Bangalore, we have Hyderabad, Kolkata, and Delhi, right? So you can see that New Delhi is the one with the highest price over here, right? With the one with the highest price, followed by Cochin and then Bangalore. Okay, and there's one thing that we need to actually notice over here. See that we have New Delhi, then we have Delhi here, right? But if we think about it, you can see that we have only one airport at in Delhi, which is the Indira Gandhi International Airport, right? So as they input the data, sometimes they use New Delhi, sometimes they use Delhi. So it's our task to actually prepare that. So instead of New Delhi and Delhi, we're going to actually merge these two, right? So whenever we see New Delhi, it's just the same thing as Delhi, right? So we're going to prepare that one. So what are we going to do is to now if you see the value counts over here, you can see that we have Delhi here, and then we have Delhi here, and then we have New Delhi here. So we're going to deal with that, right? So what we're going to do is that we're going to loop through our DF data set, and as soon as we see New Delhi, we're going to replace that New Delhi with Delhi. Okay, and we're using in place equals true over here, so that's whatever change that we do over here will actually reflect in our original data set. Okay, so that's basically what we're going to do. Now if we check it again, remember that earlier on when we did the value count, we were having Delhi and the new Delhi. So let's check the unique ones that we have. So you can see that now we have only Delhi, then we have Bangalore, right, and then we have Cochin and Kolkata and Hyderabad, right. In this case we don't have Delhi and New Delhi in this case, right. So we can do the same thing. We can plot the same graph that we plotted earlier on, right. You can just do the same thing again. Now in this case you can see that we have our Delhi, we have Cochin, Bangalore, Hyderabad and Calcutta over here. Okay, now in this case we don't have New Delhi and Delhi. Now you can see that different thing has arrived over here. You can see that now it's not New Delhi which is having the highest price as it was showing us over here, as New Delhi having the highest price. In this case you can see that that is not true. It's just Cochin which is having the highest price, followed by Bangalore. All right, so this is basically what you can actually see in there, right. And what we're going to actually see again is the heat map, right. Try to see if there are any data points which are highly correlated over there, right. Then we can actually deal with it. All right, now if you see the bar that we have over here, right, what it's saying is that as it's getting to low value, right, as it gets to low value, then the color becomes very dark, meaning that the correlation over there is very low, right. But as it gets lighter, like as it gets white, and that is when we have higher correlation. That is 1 over there, right. So as the color gets lighter, for instance, if you see the diagonals over here, right, the diagonals we have 1 1 1 1 1 1. Of course it's going to be like that because it's just a correlation between a variable and itself. So it's actually going to give us in that case which is going to be 1 1, which is a perfect correlation. But we don't actually need that, right. We don't actually need that. What we need is a correlation between a variable and then another variable, right. So we don't want to we are not interested in this 1 1 1 1 at the diagonals, right. What we're interested in is a correlation between, say, if you pick one variable here, right, if you pick one variable here, we want to see the correlation between the variable and then another variable, right. And then we can actually trace that and then see the correlation value that is actually existing over there. Okay, that's basically what we're interested in. All right, so if you see the values clearly, right, so let me actually zoom in so that you can actually see. You see that the values are very less, right. So in this case you can either use half of it, right. You can use half of that, either the upper part or the lower part, right. So whatever is at the upper part is the same thing as whatever is at the down part. So whatever is over here that you can see is the same values that you can actually see down here, right. So there's no need considering both sides of this. There's even a way that you can actually plot this halfway. All right, now if you zoom in, you can actually see that we have very, very low correlations in there. For instance, we pick the correlation between Indigo and Air India is actually negative 0.22. It's a negative correlation, but it's very low, right. As the color is actually indicating, right, as it gets darker, then it gets the correlation becomes low, right. So you can see that most of them are actually having low correlation, with the exception of maybe destination, right, destination Cochin, which is also having high correlation with source Delhi, right. And then you can also see that destination Kolkata is also having a high correlation with source Chennai, right, which is 1 over here. Okay, with the exception of that, which is very few, which is just 1, 2, and then 3 of them, right. The rest are very, very low. Maybe the one which is a bit high, 0.49, something like that. Right, the rest are very, very low, right. So you can see 0.0037, right. It's very, very low correlation. So we are good to go. We are not going to face any multicollinearity problem over here. All right, so since that is done, what we're going to do is to use this one hot encoding on those categorical variables, because now we cannot actually build a machine learning algorithm using those objects, right. So what we're going to do is to actually use one hot encoding. In this case, I'm going to do it manually over here. I'm going to use this map function, right. So what I'm going to do is to with the total stops column, right? What I'm going to actually do is to use this map function, and I'm going to map each of these. So we have non-stop, we have 2 stops, 1 stop. So if I see non-stop, I'm going to map it to 0. That's I'm going to replace it with 0, right? In a more low term, I'm going to just replace it with 0. For instance, 2 stops, I want to replace 2 stops with just 2, right? If I see 1 stop, I want to replace it with 1, right? I want to replace it with 1. If I see, say, 3 stops, I want to replace it with, say, 3, right? If I see 4 stops, I want to replace it with 4. So that's basically what I'm going to do. We could have used the inbuilt function, one hot encoding inbuilt function to actually do that, but this one is fine. I can also do this, right? So there are several ways of doing it, right? And then for the airlines, right? For the airlines, I have different airlines in there. I cannot use Indigo, Air India, Jet Airways. I cannot use that one in built-in algorithm. So what I'm going to do is to actually create a dummy, just make them dummies by using this get dummies function, right? So that's basically what I'm going to do. And then after that is done, what I'm going to do is that, don't forget that over here I'm getting Air India, Air dummy over here, Air dummy dataset over here when I created the dummy variables, right? And then I'm going to do the same thing for the source, right? The source and the destination, right? So I'm going to create dummy variables for the source variables and then the destinations. For instance, I have source to be, say, Delhi, Kolkata, Bangalore, right? So I want to actually create dummies for them, dummy variables. Dummies, they are nothing but just some zeros and ones in there, right? So whenever I encounter, say, Delhi, I will mark it to the 1, and all the other source will be 0, right? That's basically what is going to happen. So when I show you the result of the data set, you're actually going to get that. All right, then after that, I put everything together. That is the Air dummy, right? And then the source destination dummy, right? And then my original df, right? So the Air dummy will be there, my source destination df dummy variable that I created, that is source and the destination dummy variables, and then my original data set. So I'm going to put everything together over here, right? I'm going to put everything and I want to concatenate this based on the columns, right? So I don't want it to be on a row form, right? So I want to be on a column, so I use axis equals 1 over here, right? Now these ones, I don't need them anymore. For instance, the source, the destination, and then the airline, I've already dealt with them, right? I've already created a dummy for them, so I don't need them anymore, the original ones, right? I just need the dummy ones that I created. So I'm going to drop them, and then let's see the new data that we have over here, right? So as I said, if you created the dummy for, say, any column, for instance, what we did for the airlines, right? So as soon as I encounter, say, Air India, I mark it with 1. All the rest, for instance, here might be a Go Air or Indigo might have been there, or Jet Airways might have been there. So that one will be 0, right? All the rest will be 0, right? All the rest will be 0 except Air India, right? So here was Air India, right? So if you see the original data set, let's go a little bit up. You actually get to understand that. Let's actually go and see that. You can see that here was Indigo, right? So that one will be 0, and then here was Air India, so that will be 1. Jet Airways will be 0, right? All of them. So if this column is Air India, then only Air India will be marked with 1. All the rest will be 0. If this column was Indigo, then only Indigo will be marked with 1. All the rest will be 0, right? So basically, that's what get dummies will actually do. It will create a new column for all of them, right? And whenever it encounters the column name, it will mark it with 1. The rest will be 0, right? For instance, Indigo here there was Indigo here, so that will be marked with 1. Here there was a different airline, so that will be 0. So I see here there were Indigo, so that will be marked with 1, right? If you see it again, right? If you see this again, right? Let me show it from here. Let me see the one that was a bit up. So if you this one is just the first 3, right? Let me see the first. Let me go a little bit up. Okay, so you can see that we have indigo here, and then we have indigo, right? So that's why you can see 1 and then 0011, right? So all here is going to be 1, right? So if this column is actually indigo, then it's going to give you 1 here, and then 0, then 0, then it encounters indigo again, so it's going to be 1. It encounters indigo again, so it's going to be 1. Here will be 0, here will be 0, here will be 0, and then here will be 0, right? All the way to the last one. So that's what it's going to do in the column. That's what the get dummy function is actually going to do for us. Okay, so I hope you have an intuition about what this get dummy is going to actually do, right? And then now we see that we have all the numerical columns over here, with the exception of the additional information, which I don't actually need. I'm going to actually drop that, right? I don't need that column, right? So I will actually drop that. Now you see that initially we're having 10,683, and then we're having 11 columns over here, but now you can see that we have 31 columns because of this get dummy thing that we did, right? Now, so as I said earlier on, we have the training data and the testing data. So earlier on we were dealing, or what we were dealing earlier on was the training data, right? And so we can also do the same process that we've done earlier on with the same process that we've done for the training data. We can do the same thing for the test data too, right? We can do the same thing for the test data too. So what we're going to do is to actually load this test data. So it's also named as test set XLSX, right, which is an SL format. So we use read underscore SL to actually read that. Okay, and then we store it in a variable called df test, right, just our test data, right? Now if we see what is inside, right, it's just the same thing, the only thing that is not present here is the price, right? The only thing that is not present here is the price. If you see the if you see this one over here, which is the training data, you can see that that one was having the price in there. It's having the price. So after additional information, there was price in there, but the test data is not actually having that. So that's the only difference that you can actually see, right? That's the only difference that you can see, that after additional information you don't have the price over there. That's actually the only difference that you can see. So in the same process that we did for the training data, the same process. So in this here, I'm putting all of them in just one single cell, right? So if you remember, for dates of Jenny, we converted everything to date time, right? And then we created another column called day of Jenny, and then month of Jenny. Then what we're interested in is the day and then the month, so we selected them. So that's basically what we're doing over here, all right? And then we do the same thing for the departure time, and then the arrival time, and then over here too, you can see that we are doing the same thing for the duration. We are picking the minutes and then the hour, just like we did for the training data. So everything that we did over here is everything that I'm putting in one single cell over here, right? So this is the last step that we did for the training data, right? This is the last step that we did over here. It's the same thing that I'm doing over here, right? So it's just the same thing, nothing different over here. All right, so that is also done. Now what we're going to actually do is over here I'm just dropping it, so just like we drop the ones that we don't need, right? After we prepare everything, we drop them, right? So it's just the same thing, right? So if you check the shape again, after this is the shape, this is the shape of the training, right? And then this is the shape of the test, right, that I'm checking over here. So the training is actually having this 10,682 records or rows with 31 columns, and then if you see the test is having 2,671 rows or records, and then we have 28 different columns in there. Okay, so we can see the head of our DF over here, right? So this is just the data that we've prepared for training, right? So what we're going to do over here is to actually split our data into, say, dependent and independent over here. So what we're going to do is that, as I said, we don't need the additional information column, right? And the price is our target, right? So that one will not go into the X, which we're going to use to build our model, right? And the root is also not something that we need, right? We don't need the root to be doing this, right? So we're going to drop these, right? We're going to drop the root, the price, and then the additional information. Right? The price is what our target. So that one is going to be our y over here, right? And then we are specifying that what we are dropping is in the column, so that's why we use access equals 1 over here. Okay, so that is basically it. That is done. So if we see what is inside the x, right, it's everything, right? It's everything with the exception of the root, the price, and then the additional information. And what is inside the y is just all the price, right? So the price will be stored in, so you can see that over here we don't have the price, right? So the price will actually be stored in a variable called y. All right, so that's what we're going to use to build our model. So in the next video, what we're going to do is to start building our model, right, and then do some hyperparameter tuning. So see you in the next video.